Welcome to IGS 10-minute lecture series. This series is brought by the IGS department. IGS stands for Integrated Global Studies. In this series, a professor from the department will give you a mini lecture about her or his research area.
Today, I'm going to talk about plate tectonics and the dynamic Earth with a special emphasis on continental evolution. Today, especially I will introduce how the Japanese island formed along the margin of the Asian continent based on geological studies. First, I would like to introduce the structure of the Earth. So, the Earth has four main layers: the crust, mantle, outer core, and inner core. We live on the crust, which can be divided into continental crust and oceanic crust. Continental crust is about 30 to 60 kilometers thick, whereas the oceanic crust is much thinner, only about 6 to 7 kilometers thick. Below the crust is mantle. So here is a question. So is the mantle mostly solid rock or fluid magma? My question is the mantle mostly solid rock or fluid magma? The answer is solid rock. So, although the mantle is often displayed in red color like this figure, so this looks like magma, but actually the magma exists only in the limited area of the mantle. So most of the mantle is solid rock. And then at the center of the Earth, the outer core is liquid and the inner core is solid. So today we will focus on the crust. This is a global topographic map centered on the Pacific Ocean. So it shows high mountain range on the land and large difference in ocean depths. Now let us look at this diagram. It shows the distribution of elevation on the continent and water depths in the ocean relative to sea level. So value above 0 represent land elevation, whereas value below 0 represent ocean depths. So an important feature is that the graph has two major peaks. One peak is about 0 to 1 kilometer above sea level, which representing the typical elevation of the continent. The other is about 4 to 5 kilometers below sea level, representing the typical depth of the ocean. So, in other words, Earth's surface has two dominant levels, relatively high continent and deep ocean basin. So this bimodal distribution suggests that continental crust and oceanic crust are fundamentally different. So in the next slide, I will explain why continental crust is generally higher than the oceanic crust. So this figure is a cross-section of the upper part of the Earth, including the crust and the uppermost mantle. The right colored part represents continental crust, whereas the darker part represents oceanic crust. So the thickness of the continental crust and oceanic crust are very, very different. So actually, continental crust is thick and generally stand at a higher elevation. So in contrast, oceanic crust is much thinner and lies beneath oceans. So why do they have such different elevations? Why? The main reason is the difference in density. So the continental crust has a lower density than oceanic crust. So that's why the continental crust is more buoyant and remains at a higher elevation. So in contrast, oceanic crust is denser, so it rises at a lower level and forms the deep oceans. So throughout the Earth's history, continents and oceans have moved dynamically. So this large-scale movement is called plate tectonics. Plate tectonics. So the Earth's surface is divided into several tectonic plates, and each plate moves in its own direction and its own speed. So these figures show the formation of the Himalaya as a result of the collision between the Indian continent and the Asian continent. About 50 million years ago, the Indian continent was separated from Asia by wide ocean. So between Indian continent and Asian continent, there was a wide ocean. During this time, Indian plate was moving to the north. So then as the Indian plate approached Asia, the ocean between them was disappeared by the subduction under the Asia. And finally, the Indian continent collided with the Asian continent. So this strong continental collision caused the crust to become thicker and uplifted, forming the Himalaya mountains. So this example shows that continent can move over geological time. So the Japanese islands were also formed through plate tectonic processes, although their history is more complex. Now I'd like to introduce my research on the geological history of the Japanese island. So these two figures show possible paleo positions of Japan relative to the Asian continent. The figure on the left side shows the possible position of Japan about 25 million years ago, before the formation of Japan Sea. And the figure on the right shows the possible position of Japan about 130 million years ago. So we refer to the ancient geological position and configuration of Japan as Proto-Japan. So, however, the position and origin of Proto-Japan, especially in the older geological period, are still uncertain. So until now, I have conducted geological fieldwork in several Asian countries, including Japan, Korea, and Vietnam. And these photographs show one of my field sites in Vietnam. So the area has beautiful landscape, including rivers and the ocean and some animals. So most importantly, it contains rocks that provide important information to the geological history of this region. So during fieldwork, we collected target rock sample like these pictures for detailed geological and geochemical analysis. So these photographs show the geological fieldwork in Korea. We visited deserted island to collect target rock samples. So at low tide, when the sea level was low, we are able to walk across the shallow sea to reach the deserted island. So it was a very impressive fieldwork in Korea. So during the fieldwork, we collected many important rock samples like this picture. And after returning from the field, my research group and I prepared the samples for laboratory analysis. So firstly, we make thin sections, which are very thin slices of rocks used for observation under a microscope. And we also prepare samples for chemical and isotopic analysis. And by combining these different methods, so we can investigate the origin and geological history of the rock. By combining fieldwork, microscopic observation, and chemical and isotopic analysis, we have proposed possible origins and paleopositions of Proto-Japan relative to the Asian continent. So, however, many aspects of the geological history of Japanese island remain unknown. So, that's why geology is such an exciting study. So, I hope you will enjoy learning about geology with us. Thank you very much.